Hi, my name is Joseias. This is part 2 of our volume of a pyramid. Now, we have here another pyramid. In this case, we have a triangular pyramid, of which the base is a triangle, such as the one that you can see here on this shape. Now, one of the ways to find our area, our volume of a pyramid, is to first of all find what is the area of the base. In this case, we have a triangle. So we need to find the area of that triangle first of all, and then we can multiply with the perpendicular height. But in this problem, what we find is that we've got the values of the base of the triangle. So we've got here the base of 8 centimeters, which is in this case the base, and then the height of 5 centimeters for this specific triangle. But we do not know what is the perpendicular height, because they've given us the volume, which is 60 centimeters cubed. That's the volume of the overall pyramid. But we do not know the value of the height. The first thing to do is to just plug in the formula as presented. Okay, and then we are going to do some algebraic manipulations to find out the value of h. The first thing to do, we're going to do put in the values 1/3 times. Now, the base area is the base of this, in this case, of this triangle that is here. This is the base here. So we're going to find that area. Now, the formula for area of a triangle, as we all know, or as it is 1/2 times base times height. That's the formula. So all we need to do is plug in the values. So we have this equals to 1/2 times, in this case the base is 8 centimeters times 5 centimeters, which is in this case the height. Now this will give us as area 1/2 times 8 is pretty much having 8 divided by 2, because now we assume that 8 has a denominator of 1, so if you multiply 1 times 8, that's your numerator. 1 times 8 is 8, 2 times 1 is 2, so 8 over 2 is just really 4. So we put a 4 here, centimeters, times 5 centimeters. Now, all we need to do is to multiply 4 centimeters times 5 centimeters, which gives us, in this case, area equals 20 centimeters squared. Now, that's the first step, okay? So we're going to plug in this value into the volume formula. So we have here at 1/3 times 20 centimeters squared times, now we're looking for the perpendicular height, which we do not know because it's not been given to us. So we're going to put h here. Now the next thing we can do, the next step is to now plug in the value of the volume, which is in this case 60 centimeters, because we need to have h as the subject of the formula instead of v. Okay, this has to become the subject of the formula. So instead of having a v here, because this is the value that is already given, and this value is 60 centimeters cubed, and that's given to us already. So we want to try to find out what is h, because we already know the volume. So we're not finding the volume here, but we're finding the height, because that's what they want us to find. Now, we're going to use some algebraic manipulation. So what we do, the first thing is to do this, is to put just the formula as it looks, in this case, which is v equals 1/3 times 20 centimeters squared times, in this case, the height. That's what we're looking for. Now, I'm going to use some algebraic manipulations. Since we have a denominator of 3 here, with 1/3, now we can get rid of this 3 here by multiplying by this whole expression. Now, in algebra, what you do on one side, you do it on the other side. So we're going to multiply all this times 3. And if we do this side, we can also do it the same on that side. So we times the volume here times 3. Now when we do that, we have 3 divided by 3 is 1. So that can cancel out. 3 and 3 can cancel out. So we have here 3 times volume equals, now we're going to be left only with this expression here on top, which is 1 times 20 centimeters squared is just 20 centimeters squared. So we're going to have 20 centimeters squared times the height. Now this is now a much simpler problem. We can plug in the value of the volume already if we want to. So we can write 3 times, in this case, 60 centimeters cubed. So if you can notice, that's a substitution. We're substituting V, volume, by the value. Okay? So we're not using V anymore, which is the volume, but we're using the actual value of the volume. Okay? 3 times 60 centimeter cubed equals 20 centimeters squared times the height. Now the next step now is we have this. We still don't have h as the subject of the expression. Now to do that, we will need to again use algebraic manipulation and divide all this expression by 20 centimeters squared. And then if we do it on this side, we have to do it on the other side. So divide it by 20 centimeters squared. Now 20 centimeters squared divided by 20 centimeters squared is just 1. So that cancels out. Okay? So that's just 1. So that means 1 times h is just h. So we have here then 3 times 60 centimeters cubed over 20 centimeters squared equals, in this case, h. And that's what we wanted, because we wanted to have h alone, it's being the subject of the formula. Now h is the subject of the formula. Now because h is the subject of our formula, then we can find what is the value of h. Now we can then rewrite it. Another way of rewriting this is to say h equals 3 times 60 centimeters cubed over 20 centimeters squared. That's the same thing pretty much. I just rewrote it. I put h in front here. It was at the back here and here is in front. Now, all we need to do is to multiply 3 times 60. In this case, it gives us 180, right? If we multiply here quickly, 60 times 3, 3 times 0 is 0, 3 times 6 is 18, so that's 180. So we have h equals 180 centimeters cubed over, in this case, 20 centimeters squared. Now we can transpose it to this side because we don't have enough space over there, and then we can conclude our problem on this side. And we're going to have h equals 180 centimeters cubed over 20 centimeters squared. Now we just need to do common division, so 180 divided by 20. Now I know if I divide 180 by 20, it gives me 9, because 9 times 20 gives me 180. So h equals, in this case, 9. And then we have to work out as well the value of centimeters cubed and centimeters squared. As we know in algebra, if we have, in this case, centimeters cubed divided by centimeters squared, what happens is here, because the base is the same, the exponents are different, we're going to subtract the exponents and maintain the base as algebraic rule of exponents. So we have centimeters to the power of 1, because when we do 3 minus 2, in this case, if we do 3 minus 2, we have 1. Alright? So we have here just centimeters. We don't have to write the exponent of 1, it's just centimeters. So we have 9 centimeters. And with this is our final result for the height that we're looking for. Thank you very much.